All right, guys, we are going to solve some longer, more complicated equations today. And you're saying to yourselves, Mrs. Russo, we were just getting good at solving the regular equations. Why are you throwing fractions in here? But I love this lesson. It is, I like to say, my gift to you. I am going to show you how to get rid of fractions within an equation, how to make this a whole lot easier to deal with. You could brute force this, get common denominators, and do what you need to do with the equations, but I'm going to make your life so much easier today. You will be forever thankful for this day, October 16th, or October, whatever Monday is. I don't know. Okay, so what we're doing here is we are looking at this equation, which is kind of complicated. 5/3 x, 7/2 x, minus 11/4, blah, blah, blah. A lot of fractions. I'm going to clear out these fractions. I'm going to use the property we spoke about this week called the multiplication property of equality, which says I can pick any number I want to and multiply both sides of that equation by whatever that number is and keep that equation balanced. So I want to think of a good number to multiply by. I could multiply by 27, I could multiply by 136, I could multiply by pi, or I could multiply by a useful number, a number that will wipe out all of those fractions at the same time. Can you see what that number is going to be? What number would take away all of those fractions, wipe them all out? That number happens to be the least common denominator of all of those denominators. So out of 3 and 2 and 4, the least common denominator out of all of those denominators would be the number 12. If I multiply both sides of the equation by 12, again, I keep that equation balanced, but this is going to clean things up nicely. This is kind of like the distributive property that we talked about last week when we had the fractions, right? Multiplying here and multiplying here. But watch what happens now when I do this. I picked that 12 because 3 goes into 12. 3 goes into 12 evenly, goes in 4 times, and 4 times 5 happens to be 20. That's 20x. 2 also goes into 12. 2 goes into 12 6 times. 6 times 7 is, that would be a minus 42x. On the right-hand side, same thing. 4 also goes into 12, goes in 3 times. 3 times 11, minus 33. This equation is much nicer than this equation, right? Much easier to solve. They are exactly the same equation. They have the same values on both sides. We just kind of changed what it looked like a little. Isn't that a nice thing to know how to do? My gift to you, let's clear out fractions. Now, I want you to note, we can only do that because this is an equation. There's an equal sign in here. With any old expression, if there's no equal sign, we can't do that. You can only do this when we're multiplying on both sides of the equation by the same thing. All right, so now we combine some like terms. That's minus 22x equals minus 33. Divide by negative 22. And we do want to simplify our fractions as much as we can. So 33 and 22 both divisible by 11. So this would be 3 over 2. We may get some fractions as answers for these problems, but they won't be crazy fractions like 37/19. They'll be halves and thirds and fourths. Okay, so there is our answer. Again, the idea here, let's clean up that equation. This equation, exact same thing as this one, but I would much rather solve this equation than the first one. All right, so the idea there again, find the common denominator, multiply both sides of the equation by that common denominator, and watch the math magic happen. The fractions go away. Let's try another one. So similar kind of question here. I'm going to scan through, look at all those denominators, and find the least common denominator of all the denominators, so the lowest common multiple of all those denominators. Remembering that we've got just a p here as I scan through. The p by itself, remember that's 1p. I can make it a fraction by putting it over 1, and that's going to come up in a minute. So let's see, my denominators, 3s, 1s, and 2s. Least common denominator would be a 6. So I'm going to multiply on both sides by 6. 3 goes into 6 twice, and 2 times 13 is 26. Now here's the part students forget. Once we get the hang of this method, it's really great, really easy to do. Here's what kids forget. We also, even though that's not a fraction, we also need to multiply the p by the 6. So 1 goes into 6 times, and 6 times p is 6p. Okay, so focus on, make sure if there's not a fraction, make sure we still multiply that term, okay? Next one, 2 goes into 6 3 times, and 3 times 3 is 9, so minus 9. And then 2 goes into 6 3 times, 3 times 5 is 15. We're going to say 15p. And again, this equation, exact same equation as this equation. It just looks better. It's easier to solve for us. So it's a great step to do to clear out fractions. We use this idea all the way into calculus. So again, my little gift to you today, but it's one that's going to serve you well going forward. All right, our like terms here, 6p and 15p would be 21p minus 9 equals 26. I'll write that 26 on the right this time, doesn't matter. And then I could add 9. 21p equals 35. And I'm going to divide by 21. So p equals 35 over 21, but I do want to simplify. I want to reduce my fractions as much as I can. Here's where knowing my multiplication tables comes in handy. Those are both divisible by 7. Divided by 7, I get 5/3. You could, of course, write that as 1 2/3. In algebra, we tend to take the improper fraction. I would rather it be written that way at this point, okay? I certainly wouldn't mark it wrong if you wrote this. That's fine. But we don't have to. We can keep it as an improper fraction. So I'm going to do just one more with you. You can pause here and give this a try if you want to. There is another wrinkle in this one that I want to point out. And as I look at it, it's 151 over 18 equals negative 4/3 x. And then I've got this here, plus 2 plus 1.5. Well, plus 2 plus 1.5 is really the same as plus 3.5, right? I can combine those like terms together. But if I'm going to use this idea of clearing out fractions, I should change that to an improper fraction first before I do anything else. So I'm going to rewrite this as 151 over 18 equals negative 4/3 x, negative 4/3 x, plus, and 3.5 would be 7 over 2. All right. Now I can scan through here, and my least common denominator of all those denominators would be the number 18, which happens to be our first denominator. That's okay. Multiplying on both sides. And now I can start this division process. 18 goes into 18 once. 1 times 151 is 151 equals, all right, on the other side here, 3 goes into 18 6 times, and 6 times negative 4 is negative 24. Be careful here that you write your variables in as well. There's an x with that 24. And then 7 goes into 18 9 times, and 9 times 7 plus 63. All right, so we have some kind of ugly numbers here, but let's see where this takes us. If I subtract 63 from both sides, I get 88, I think, equals negative 24x. Divide through by negative 24. And again, knowing my multiplication tables, I know 8 goes into both of those values. So it would be 11 over negative 3. Now just a note about the negative sign. You can put the negative in the denominator. You could put the negative in the numerator, same thing. In books, a lot of times what you'll see is the negative sign will be right next to the fraction bar. All three of these things mean the same thing, so it doesn't matter to me where that negative sign is. Just make sure it's there. All right, if you missed any of those steps, go back and watch another problem. Watch a problem, watch me do it over again, okay? Really great thing to know how to do because it simplifies our lives so much if we can clean up those messy questions and get rid of the fractions. All right, so I have 8 problems for you to do on a PDF. Give them a try, check the answers, and see how you do. You do not need to submit anything. All right, just try it, check, see how it's going, and we will talk next time I see you. Okay, good night, guys.